In this video, we're going to talk about what an indifference curve is mathematically. So in the previous video, we talked kind of about the theory of an indifference curve, what's an indifference curve, showing all of the combinations of bundles that are equally preferred or consumers indifferent between them. Mathematically, what an indifference curve shows us is marginal rate of substitution, or a consumer's willingness to substitute between the two goods. So consider point A here, where the consumer has 16 clothing and about 1 food, and point B with 10 clothing and 2 food. What this is showing us is, again, the consumer is indifferent between those 2 points, makes them equally happy. What it shows us is what we call this marginal rate of substitution. And it's really just the slope of any particular indifference curve is the marginal rate of substitution between 2 goods. And again, if you're looking at point A and B, what it's showing us is that the consumer was willing to substitute or trade 6 of their food in order to get, trade 6 of their clothing to get 1 additional food. And that made them equally happy as they were before. All right, now that the consumer has 2 food, the consumer is now willing to substitute or trade 4 more of their clothing for an additional food, and that makes them equally happy. What this particular indifference curve is showing us is diminishing marginal utility. Or in other words, the slope is getting flatter. As we get more food, we're willing to trade less clothing for additional food, right? Up here at point A, when we didn't really have very much food, additional food made us very happy, and we were willing to give up a lot of clothing for it. Down here at point E, where we already have a whole bunch of food, getting an additional unit of food doesn't make us as happy. We're only willing to give up 1 unit of clothing once we already have 4 food for an additional unit of food. Okay, so the marginal rate of substitution is the slope of any indifference curve, and it's showing us a consumer's willingness to substitute one good for another. All right, again, that convex shape or bowed like this is showing this diminishing marginal utility, but that's not the only case that we could have. We could have a case of constant marginal rate of substitution. So here, marginal utility is always constant, right, between the 2 goods. And if we have these linear indifference curves with this constant marginal rate of substitution, constant marginal utility for each good, we call these perfect substitutes, right? So this consumer likes apple juice and orange juice equally as much. They're willing to trade 1 apple juice for 1 orange juice, no matter how many apple juice or orange juice they already have. Right, 2 apple juice for 2 orange juice, and so on. And perfect substitutes don't have to be in a 1-to-1 ratio. I'll do some examples in my example problems where this ratio isn't 1-to-1, and that'll just change the slope, but it'll remain linear. Right, so suppose that the consumer liked apple juice twice as much as orange juice. Then it takes 2 glasses of orange juice for every apple juice to make the consumer happy, and that's going to flatten this curve, right? If I like apple juice better, then I might be indifferent between, say, 1 apple juice or 2 orange juice. I need twice as much orange juice as apple juice to make me equally happy because I like apple juice better. Right, another case is perfect complements, and this is when you need to consume the 2 goods in a particular ratio. So here we have the examples of left shoes and right shoes, right? If you have 1 left shoe and 1 right shoe, here's this point, and I guess this would be U1 happy. Having a second left shoe doesn't really make you any happier, or likewise, having a second right shoe without any additional left shoes doesn't make you any happier. So these indifference curves are right angles. Again, this is a case where you have to consume the goods in some sort of ratio. Again, doesn't always have to be one for one. Another example of this might be car tires. Usually we think of needing 4 car tires for every car. So you have a 4-to-1 complement ratio there. Right. Now, just understanding the mathematical utility functions which end up producing these indifference curves, and we'll show how they produce these indifference curves. But consider this utility function, just a mathematical function of 2 goods, food and clothing. And for any combinations of food and clothing, you can see how happy you are or how much utility you have. So this little table gives you a few combinations of food and clothing. We plug them in, we see what the utility is. Right, what we can infer from this table is that A and B must be on the same indifference curve, right? Because they both give the same amount of utility, 14. So let's have a look at this utility function. Once again, we're talking about food and clothes. Utility is a function of food times clothing. All right, so mathematically, we can actually find what are the points on any given indifference curve if we know what is the utility level. So we've specified utility level of 25, and we would just want to find different combinations of food and clothes such that F times C equals 25. All right, so one possible combination is 5, 5. We see that we plug that in, we get a utility of 25. Here we have 10 food, so we must have 2.5 clothing. Utility is 25. Likewise, 10 clothing, 2.5 food, we get utility 25. All right, we could do the same exercise, so maybe it would be a good exercise for you at home to see if you can figure out what would be a couple of points on this indifference curve, U equals 50. What would be a couple points on this indifference curve, U equals 100, given if we have this utility function FC. And once again, you're just finding combinations that F times C equals, say, 100. So the point 10, 10 should be on this utility, this indifference curve, 100. All right, the last point that we're going to make is that this is sort of a ranking only, especially when it's interpersonal. So there's some extent that you could maybe say that a utility for you of 100 is twice as good as a utility of 50. But what about if we're comparing me versus you? What does it mean for me to have a utility of 100? Is that the same thing as how you feel with 100 utility? It's not exactly clear. So these utility functions are really only very useful for one particular person, and it's kind of more of a ranking system. Higher numbers are better. Okay, so in the next video, we'll talk about budget constraints for a consumer.